So over here I'm given the root of a binary tree, and it says each node in the tree has got a distinct values. Now I need to delete the nodes given in the two order array, two delete array, and I need to return the we will be left with a forest. Okay, so and I need to return the roots of the trees. Okay, so over here 1 2 3 4 5 6 7, so I need to delete 3 and 5. So if I delete this 3 from here, so this part will go away, this part will go away, and this part will go away, and I need to delete 5 as well. So for deleting 5, when I delete 5, this part will go away. So I will left with a tree, I'll be left with a tree, something like a tree, something, sorry, I will left with a tree. This would be my first tree, second tree, and third tree. So this forms a forest. So I need to return these the starting nodes. So this is 1, this is 6, and this is 7. Okay. Now I'll show you how to solve this. So my first step over here to delete is given as a vector or an array. So I'll convert this into the set for fast lookup. Okay, so I convert these elements into a set. Now I have got this 1 2 3 followed by 4 5 6 and 7. So what I do, I go left down, I reach my bottommost nodes. So I go left, is it the bottommost nodes? So for the condition for a node to be the bottommost, the left child should be null and the right child should be null. Over here I don't see that, so I go more left. So in this case I see my left child is null and my right child is null. Okay, now I go and check whether this 4 is there in my set to be deleted. It is not there, so I go back. So this returns 4 again. Now I go to the right. So when I go right, it has got null on the left and null on the right. Now I go and check in my set, do I need to delete this? So it says yes, 5 is present. So what I do, I delete this and I return null over here. Okay, so now since I have returned back to this node, I go and check whether this is present in my set. This is not present, so I simply return 2 back to the node. Then I go on the right side. Okay, and again I need to reach the bottom. Since the left child of 3 and right child of 3 are not null, it means 3 is not the bottommost node. So I go further left. So over here I encounter 2 null nodes. So I check whether 6 is present. So it says no, 6 is not present. So this returns. Now again I go to the right of 3, the right child. So it says 7 is a base node since it has got left child and right child as null. So I ask whether 7 is present in the root node, delete set. So it says no, so it simply returns this thing. Now I come to 3 and I ask whether 3 is present in the set or not. So it says yes, 3 is present. So what I do, I delete this 3 and I return a null. And I check if the left child of 3 is not null, then I push this into my result. And also I check if the right child of 3 is not null, then I push this into the result. So at the end I will be left with something like this, a 6 and 7. Okay, and I will return this result. So over here my first step would be to create a result vector. So I say let mutable result is equal to vector new. Okay, so this will store the root of all remaining trees, and I convert the deletion list into a hash set for fast lookup. So I say let st, this is hash set of type i32 is equal to 2 delete this is into iterator dot collect. Okay, now I process the tree, so I say let new root is equal to self. This would be, I'll call the helper function, I'll send in the clone of the root, my result, as well as my hash map st. Okay, now if the original root was not deleted, I will include it. That means if my new root is sum, in that case I would say result dot push new root. Okay, after coming out of here I would return a result, that is all the tree roots in the forest. And since I have used hash set, so I will use standard collections of hash set. Okay, so this stores the value to delete with big O of one lookup. Okay, now I need to write the helper function. So I will write the helper function. Now it takes in the root, which in the helper function I'll call it as current. Okay, so this will be of type this over here. So this is current node to be processed. Then we would receive a result, so this will be a vector. Now this will store the roots of the remaining trees. Okay, so this will be something like this. Post that I will also have st, which is a hash set. Okay, this is of type i32, so this set containing the values to delete, and this over here would return me a node. Okay, my first check is if my current is null. Okay, that is none. In that case I would simply return none. Post that I say let my node is equal to current dot, so I extract the current node. Okay, now I recursively process the left subtree followed by recursively processing the right subtree. So I say let my left, I can use this helper over here, so I can use a helper, so this will be node and this will be borrow. So and I need to then say left dot clone, since I am calling for the left child. Similarly I can do this step for the right child as well. Okay, now after calling these two nodes, I update the current node's children after recursion. Okay, so what I do, let mutable node mutable is equal to node dot borrow, and I do node underscore mutable dot left is equal to left. I repeat this step for the right. Okay, now I get the current node's value, so this will be let val is equal to node dot borrow dot val. Okay, post that if my st, I check if the current node should be deleted. So I say if my st contains val, then if my left child exists, it becomes a new tree node. So if let sum, this will be left child is equal to node dot borrow left dot clone. In that case, I will push this into the result. So this will be result dot push some left child. And similarly, if my right child exists, it becomes a new tree node. So I copy this and I say if some right child node dot borrow right clone. So in that case, result dot push a right child. Okay, now I need to remove the current node from its parent. So I return none, and my else case would be I return the node itself, keep the current node. Let me run it and see. So I got an error over here. So let self helper node dot borrow left dot clone. Oh, over here they shouldn't be there. Now over here, if left child, this shouldn't be equal, this should be a single equal. So now I got let my new root is equal to self helper root dot clone. This and should have been over here. Let me submit this.